Okay, so we've got a rectangular sheet of metal, okay, and the corners have been cut out, okay, and obviously these are squares here there, because it says of side X, okay, here. So all the four corners have been cut out, and then it says it's folded, these sort of flaps, if you like, are folded along the broken lines to create a cuboid. So if you think about it, those sort of flaps there folded up, okay, and the same there, with the flaps then folded up, it would create a box, wouldn't it, okay, or cuboid. Of course it won't have a lid, won't it, because these will be the sides, okay, it won't have a lid, but it does say, doesn't it, up here, open tank, in the form of a cuboid. So it says then in part A, show that the volume of this tank is given by this here, okay. So what we need, of course, for volume, I've drawn my sort of cuboid here. We need to work out length times width times height. That's the formula for volume of a cuboid. So we need to work out what the length is, okay. So we need to know what that length is there. We need to know what the width is. We need to know what the height is. Straight away, I know the height is going to be X. Yeah, I hope you could see that there, because essentially it's just these flaps that are lifted up, yeah? So the height's going to be X. That's kind of straightforward. The length, okay, you've got to think a little bit about this, because if you think about it, the length of the whole rectangle is 24, but I only want this bit here, don't I? I want the length here going from... There you go. So it's not going to be quite 24, isn't it? It's going to be less than 24. And if you think about it, because we know that's X there, and we know that's X, the whole of this would make up 24, wouldn't it? Okay, because the whole of that would be the total length of the rectangle. But we just want to cut that bit off, don't we? So we're going to take away the X there, and we want to take away another X. So this will be 24, the overall thing, take away the X at that end, and take away the X at that end. So that will be 24 minus 2x, okay, that's what the length would be. The width, okay, of the rectangle, of course, will be this here, okay, the width of the cuboid. So, because we know that the whole width of that rectangle sheet is 9, and again, you know, it's made up of now the X, that length, and X there. All you've got to do to work out this is do 9, take away that X, and take away that X there, so take away 2x. So we know then the width is 9 minus 2x. So we've got our dimensions, and all you've got to do then is multiply them together, okay? So you've got the length, which is 24 minus 2x, times the width, which is 9 minus 2x, and then times the height, which is x, okay? All right. So let's just take our time on this. Let's just do these two brackets to begin with, okay? So 24 times 9 would be 216. 24 times minus 2x, so I'm doing FOIL on this now, and that, okay, will be minus 48x. So that's the outers. The inners then, minus 2x times 9 is minus 18x. And then the last, minus 2x times minus 2x is plus 4, yeah, minus times a minus is plus 4x squared. So don't forget then, put that in the bracket, because I've got to then times it all by the height, which is x. So if I do that, I get 216x minus 48x squared minus 18x squared plus then 4x cubed, timesing everything in there by the x, and then put it in powers in descending order. So we start off with 4x cubed, them can go together, yeah, so we get minus 66x squared and then plus 216x. So let's see if that's exactly what they wanted. So you can see that I've got the exact answer there, yeah? Okay, now, if you didn't get that answer out, okay, it's not a problem. Suppose it just didn't work out for you, you can still go on to answer part B, okay? Because in part B, it says, find the maximum value of V, showing that the value you have found is a maximum. So suppose that you just couldn't do it, you weren't sure, you could still then just write down the formula, which is what they give you, and find this maximum. Now remember, to get maximum, okay, we do differentiation, yeah, we use calculus, because maximum value can be found by looking at the stationary point, yeah. So if we do, in this case, we think of differentiation, we think of dy by dx, but in this case it's going to be dv by dx. Okay, so you differentiate like that, dv by dx. So v with respect to x. That's why I'm doing that there instead of y in terms of x. So dv by dx. So differentiate this, bring the 3 down, so you get 12x squared. 3 times 4 is 12. And then reduce that by 1. Bring the 2 down there, so 2 times that will be 132, x to the power 1. Okay, and then 216x just becomes 216. Okay, so you say then, look, 4 stationary points, dv by dx will equal 0. Okay, so then we say, look, 12x squared minus 132x plus 216 will equal to 0. Now let's see if 12 goes into all of them. Now I know 12 goes into that, I know 12 goes into that. Does it go into 216? It does indeed. So what I can do is divide by 12. So I get x squared here, I get 11 there, and I get 18 here. So I can factorize this then to get my x. So two numbers are going to be 9 and 2, because 9 and 2 multiply to give 18. And to get minus 11, of course, make them both minus, they'll add up to give minus 11. So that means x minus 2 is 0, or x minus 9 is 0. So that means x will be 2, or x will equal to 9. Now clearly x can't equal to 9, can't it? Because if you look at the question, remember it said x has got to be less than 4.5, okay? And if it was 9, it wouldn't make sense, wouldn't it? Because you'd have 9 here, you'd have 9 there, and of course the overall thing is 9, yes? You can't have that to be 9 and that 9. Because it just wouldn't work. Okay, so you just say, look, this is impossible. So x has got to be less than 4.5. So therefore, x is equal to 2 there. Okay, so then it says find the maximum value of v. Okay, so you just plug it in there. So you say therefore, max value of v will equal to 4 times 2 cubed minus 66 times 2 squared plus 216 times 2. So if you work that out on your calculator, it comes out to be 200 meters cubed. Okay, that's the maximum. And show that it is a maximum. Well, how do we show that it's a maximum? Well, we've got to do the second derivative then, haven't we? d2v by dx squared. So if you differentiate that again, you get 24x minus 132. So when you put x's there, then when x is 2, d2v by dx squared will be 24 times 2 minus 132. So if you work that out in your calculator, it comes to minus 84. It's less than 0, so therefore it is a max volume because d2v by dx squared came out to be less than 0.